Yeah.
Hello viewers, welcome to the third part of this video. In our first and second part, we were able to import our DXF, able to prepare our columns and place it at the intervals just like this. I told you that let your column distance from each other, from this column to this column, let your column distance not exceed 5 meters for now. And we'll put our slabs, and then we'll put the slab load just like this. So that is what we have done in our first and second video. If you missed the videos, make sure you go back, you check all my uploaded videos and watch the previous ones so that we can be on the same page. So in this tutorial, you can see this is our cantilever slab, which we imported in the second video, and we put the slab load and the cantilever load at the edge, because this slab is going to carry a load. This slab is going to carry a load up to a particular level. And this side is going to carry a wall load. So we put a cantilever load. Alternatively, what I will do is I cantilever this load, put a beam, and put the wall load on the beam. So now let's look at the AutoCAD drawing so that we know where the wall load is going to stop. So go to AutoCAD drawing. So you see this is the ground floor, which we did. We have our column positions, and this is our first floor. So you can see from the wall load, we start here and it ends somewhere, it ends here. Here is a slab, the cantilever slab continue, but there is no wall. Along here to here there is no wall, it's just a slab and maybe hand raise. After the slab is cast, we can do hand raise, protect people from falling down. So just like a walkway, you walk here, then you end, you have access. From here you can have access to these rooms. So knowing the architectural plan is a key to having a good structural design. So now let's go back to Prota structure. Let's go to plan view. Okay, now you can see where our wall load is stopping. So now you can offset any of this line, any of these grids. Offset this. I say offset, then just drop it. I'm using the reference, the DXF 5. So I can just drop it here. So this axis 118, axis A18 is telling me where my wall is stopping, my wall load is stopping. Okay, then I can now have my beam. Of course, all here my beams will go, but it's only the wall load that is stopping here. The wall load will be here. So let me delete this. Go to 3D. Let me delete this. Delete this, because I want to put the beam that we can carry the wall. So go to plan, just copy any of the beam property and skip from here to here. So you say, if you say yes to split, we say no to run a straight beam. Then I run from here to the end. Yes, this one should split, it's too long. So you can have something like this. Now I may decide to delete this. Delete this beam. Okay. We decide to extend this beam. Let it go and hit here. Delete. So we have this beam. Properties, have it being created here. To here. Okay. Then I can have a column, move this column here. And have a column here on the upper floor. Okay. Then I can draw this. Have a beam here. Down to here. Okay, I have something like this. Okay. So let's look at it in 3D. Okay. I decide to have something like this. So now we are going to add our wall load along the external beam and even the inside of these beams. So we can, let's go to, before we add our wall loads, let's add our stories. Let's add and generate our stories. Okay, before we can our story, let's make some modification on our slab since we changed our arrangement, our general, our GA arrangement. And you know, GA are not the same. You may have your GA, the way I have my GA is different from the way you may have your GA. You follow the same principle. Just make sure your column to column distance or your panel is not more than 30 meters square, or your column to column distance is not more than 5 meters. This is for beginners. So now I can input my slab. Okay, there's this slab. This slab, let me delete it and do input. So I can have my slab here. Go to slab. Let me get the properties from this slab. Properties. Then I can pick from here. This cantilever slab this way. My cantilever this way is 900. From here to here is 900. So 900 minus 22 minus half of 225. And this calculator, you can say 225 divided by 2 is 1125 minus 900. You can have 87.5. So you can have here 787.5. You can update. You can pick from here to here and you drop. You can pick from here to here and you drop. You can see your slab has landed properly. This way we have okay, and escape. So now let's copy the properties of this. Then we can pick from here to here and we drop. No, this one is short. Okay, let's look at the properties. Okay, it's short. So this way our cantilever is 1, 2. From here to here is 1,200. So let me delete this. For any properties, I have 1, 2. My calculator. 1,200 minus half of your beam is 112.5. This gives 1087.5. 1087.5 and update. Okay, you can see it has gone. And escape. So you can delete this. Let's see, then have the properties of this slab. Copy from here to here and we drop it. Good. Okay, let's think this one is, let's look at the properties. See the length. And the properties of this slab. Properties. Okay, this one is correct. All these they are correct. So the next thing we do now is to insert our stories. So you can look at it in 3D if you wish. So this is what we have. So I'm taking this as my cantilever where I have beams under supporting. Okay. Okay, go to plan view. Go to building, set out, go to insert story. Now you in Prota structure from the ground to the first it's considered as one story, and then from here to the roof it's considered as another story. So we're putting 2 for a 1-story building. And we click OK. Push OK. So I've added. So to generate your stories, you have to go back to your first story and generate. Then go to building, generate story. So now the client, for this particular work, the client wants to use timber in roofing, like a normal pitch roof. So it's not going to be a slab. So I'm going to remove all the slab at that level. Then I'll copy from here. Okay. Okay, it's like, okay, I've added this. Okay, I'll copy this to this. And I'll say okay. Okay, this has copied. I can delete this other story that mistakenly added. So remove this and remove that story. So you have only this. Then you can edit your story. Edit story. The second story is just 3 meters. 3 meters. Okay. So you have something like this. So you can look at it in 3D. This is what you have. This is what you have. So now, what we are going to do now is to insert our wall loads along this beam. So you go to story 1, go to plan, go to story 1, then you can edit one of the wall, edit one of the beams, and say edit loads, then wall load. So you can give the wall thickness is 3.47 and our wall height. Our wall height is 3 meters. Then we remove the depth of the beam that is dropping, say 300. So 3 meters minus 300 will give you 2,700. Okay. So we come to this point. In Prota structure 2022, you must first come here to activate your load. Click on this line. Click on it, and your load will now be activated. So you may want to have openings. You may have openings. You click, and then you add openings if you wish. Say OK. Then you update. Then you can say OK. So you can look at it in 3D and see you have it with your opening just like this. If in case this wall, this place is carrying a window, so this is how you can also impute your wall load with openings on it. So now I can decide to copy this. I will do another one without opening and copy, because if you copy this, you can copy with the opening. So let me do another one. Edit loads, wall loads, the same distance. Okay. So I just come click here. So now I'm not going to add any wall and add any opening, so I can just go ahead and say OK. See, that's copied. So you're in charge. If you want to be exact by removing the spaces, the weight of the spaces, so you can have your wall load coming. You can have your at liberty to do that. So I can now copy this, copy loads. Okay, then I can select all the beams. Select whole shift, whole shift and whole. Select this. Then you can right click and say paste. You can do Ctrl V on your keyboard. So you have all your wall loads copied like this. Okay, are all copied. Go to plan view. You can see if any wall is not carrying this thing, you can still remove. If you can still remove it. So you see our wall load is going to stop at this grid. It's going to stop at this grid 18. So after grid 18, there's no wall load, so you can maybe the whole of this you can remove. You can delete our loads. Okay. Actually, the load stop at 18, but I don't want to. Since I'm putting it on the beam, maybe I can just draw this slab load. Just put it here to indicate the load that is coming there. Delete this. Okay. And here, okay, here we have a one. So when you look at it in 3D, you see that this is exactly what it is. This is exactly what it is. And we also remove this because I'm trying to model exactly the way the AutoCAD drawing is. So you can see starting from here. Starting from here is just a pure slab that is coming. Pure slab that is coming. But I will also remove this. Now there's no obstruction until when you come here, before we can have something like a wall crossing. So model it just like that. That is the essence of modeling. Model it the way the architectural drawing is. So you can delete the loads. Okay, so here I don't have. Okay, I can also delete this slab. No loads. And once you climb the stairs, you enter here. You move straight here to there's no loads. Delete loads. Yeah, this is it. So you can only have load at this point where you have a door to enter into a structure. Alright. So now the next thing we do now is to you can see this beam. When I copied it, it's the same property of this. It's 450, and this one is also 450. I want this one to be 350, so I will change it to 300. So I'll go to story 2. Go to story 2, and then I will select my story 2 beam. Hold select one. Hold shift, select the last, right click, and then okay, hold shift, right click, hold this, okay, you can have like this. You right click and you say properties. Then from here you can highlight all, and then maybe you can type 300. Just click on one. Select all of this. Start from the beginning. Select all. Use this as type 300. Okay, so, and all will take effect. Then you can close it. So now we can also add the wall load at this point. This wall load will serve as our roof load, because the timber, the roof members, the timber trusses, the timber lines will also add a weight and the roof covering, while the weight and the weight of people that will be climbing to roof this building will also add the weight on this structure. So we will calculate our roof load and add it on this our external this our roof beams. So all this becomes our roof beams. So let's do that. So you go to new plan, just copy, do one. Before we do that, we have columns at this second floor. We have some columns at the edges. So let's impute those columns. Okay, and then we'll have some beams that we don't need, since this at the roof, this is all is not considered as one. So we'll move this column. Say move, and click the point you want to move it to. The column will move. Okay, select move, click the point you want it to move to. Control Z. Don't want to copy. Let's say move. Let's move it here. Okay, I can move. Okay, here I can copy. I can place another column. Properties. I can place another column here. Okay, I can place another column here. Or let me move this. Move this one to here. Move. to this point. Okay, at this level, these two columns are not going to the roof. I'm deleting them. This, I'm deleting them. This one, they're terminating at the ground floor. Those architectural columns, all these beams, I'm going to move it all here. I'm going to remove this. I'm going to remove this. I'm going to remove this. That's something that you can see. I'm going to remove this. I'm going to remove this. I'm going to move this in this column. Move. I'm going to move it to here. Go to the edge. I'm going to delete this beam. I'm going to delete this and redraw. I'm going to delete this. Okay, I'm going to delete this. Go Control, delete. Click, delete. Yes. So I want to pick beam, draw here. This one's already drawn. Pick draw from here to here. Okay, escape. I may decide to leave the whole of this. Let me look at it. If it's wide enough, if it's too wide, or if it's okay, pick from here to here. It's 5.4 meter. 5.4 meter. Okay, since we have a principle of breaking it, let's break it. We will not exceed our principle, but if I can still go ahead and design 5 meters, 6 meters. So let's have this. Then we delete this. Okay, let's move this first. Move to this point. Okay. Okay. So I can delete this. I can delete this. Okay. I can have another one drawn. Pick one drawn to this point. So Z is not touched. Let's do it again. From here, make sure it touches the intersection. It can land well. And you notice these two columns, they're not sitting. You can see they're not sitting properly. So you can copy them and change their eccentricity. Copy this, hold Control, copy this, right click, properties, and you can change it. So you can see E1 is 20. So these are you're moving it one side, so I want it to be center. Put it 0 and update. You can see it as taking position now. Okay. So now I can delete this column. Since I have support, I can have it separately drawn at each support. Properties. So I can copy from here to here to here. Okay. So now this is what we have. This is what we have. Okay. Okay, I may decide to delete this one. I decide to, okay, let me just leave it. Let's look at it in 3D. So this is what we have. Yeah, so it's pretty it. So I decide to extend this column to just block it here. Okay. Let me extend this beam. properties. Let's pick it from here to here to cross. Okay, so you have something like this. Okay, let's delete this and assign. Delete beam properties and take it to this point. Okay, this beam also let's divide it. Let's draw at each point. Now go straight from here to here to here. Okay, so this is what we have. This is pretty good. It's pretty what the building looks. So that is the essence of modeling. So now what the next thing we do now is to impute our roof load. Put our roof load on these roof beams. All these are your roof beams, so they want to carry the roof load. So let's quickly do that. So you can copy one of it, edit loads, go to wall loads. Here you can see it's for average load 9.36. But we want the load, my roof load, based on my calculation, I have 1.5. Let's say 1 meter. There is 1 kilonewton per meter. So to have my 1 kilonewton or 1.2, that means I can change the height to, let's say, 500, or let's say 450. Okay, and this has given me 1.5. So if I change it to 400, so they give me to 1.3. Okay, let me give 400. Okay, I can come here, click on this, and make it add. This 1.3. This is my estimated. Based on my calculation, I have 1.2 something. I'm just using this. Okay. If after analysis it fails, then I may decide to reduce the load to be exact. On this. So now you can copy loads. So copy this load and you select the beams you want to paste it. Paste the load on. Select the beams you want to paste the loads on. Do it in plan view, you can do it in 3D. Select the load, select the beams you want to paste your load on. Once this is selected, okay, it is selected, you have it here too. So you right click and you say paste loads, go Ctrl V, and you have something like this. Okay. So now this now becomes the roof estimate that is coming on this. Okay, this beam I have not put anything because, okay, let me delete it and redraw. Okay, properties and from here to here. Okay, I can select it and paste. Already copied. So this is what we have. So the next thing we'll do now is to define our beam end conditions. I like doing it to be more accurate in my analysis. So I'll first go to level 1. Let's go to level 1. The beam end condition. This beam at this point is going to be hinged. This one is going to be hinged. So I will select this beam. Select this beam. one good thing with Prota 2022, as you select it, it indicates your J end, indicates your I end. Like the other versions, you begin to know which one is J end, which one is I end. With 2022, that solved that issue. So you right click and then you say update beam end condition, and then now is what? J end. Apply the selected beam. You can see this dot. This is not telling you that the moment at this point is 0, and this is a continuous beam. Continuous beam. So you can come at this. Okay. So now you can select all the beams that are ending. They are not continuous, and update your beam and your main condition. Like this one, you can select this. You can also select this. Select this. Make sure you select it. Select. Hold Shift. Select. Okay. Select this too, then right click, update beam end condition. Both ends are hinged. Selected beams, so you can have it. And then this one we will mark our cantilever. Now this is a cantilever beam. We'll just mark it as a cantilever. Right click, and you can say mark cantilever. So if you mean that here now is our J end, here is supported, here now is now you want the one is not supported. It's being cantilevered on this. So you can say I end, mark cantilever end, you can I end is free. It's supported by beam actually. Okay, so this is what I like doing. And then you do the same thing on your first floor, on your roof beams. Do the same thing on your roof beam. Go to second story. Go to second story. Second story, and you do the same thing. This the beam end condition. Take time and do it. Here is you hinge it at this point, and here is I end. Update beam condition. I end. Selected beam. See, only whenever you see this dot, you know that it has taken effect. So I can select this, update beam end condition. Now I still have I end. I can show. I can select this beam end condition, update beam end condition. I can have J end, update end condition, J end. Okay, so now this is how you do it on all. Okay, so I will pause and then do it, and make sure you do it. I will do it one by one to save the time. Alright, so the next thing we do now is to go back to our slab and perform our slab strip. Go to story 1, perform your slab strip, how you want the slab reinforcement be. So go to slab, in the X direction, you can pick, this is beam to beam. So you can have it, this is beam to beam. Hold your control key, I can go straight, you can click. Okay, give it time. Okay, you can see your reinforcement. Your reinforcement has been added, so you can, here is what, Y12 at 250. Okay, you can select from here, and select from here. But before you strip your slab, before you strip your slab, first you select all the slabs. Select all the slabs. Hold shift. Select this and right click it. Set slab type automatically and set it. Okay. Okay. So now you can now go to slab strip. Strip. Okay, beam to beam. As the end condition here is beam and it's ending at beam. So you can pick from here, hold your control key and click here. You can see your reinforcement is Y12. So I can still hold here, hold control and you can drop here. You can click here, hold control and drop here. Okay, and click here, hold control and drop here. Okay, and click here, hold control and drop here. Okay, so you can do vertically, change it to Y. Now you send beam to beam. So I can start inside here, inside the slab. Down. So this reinforcement is one that can go all through. If I don't want, I can do it on this panel too. If I go to detailing, I can reduce it. I have something like this. Okay, this one is starting from beam. We enter inside slab beam. I enter inside slab, so I can start it from here. I can end it inside the slab. Hold control, I can drop. Slab section insufficient. Okay. So now the thing is complaining maybe the spacing is too wide. In case you want to change the spacing of this, you can go to your settings. Go to your slab settings. Rebar, then you can change your maximum spacing here to be 200. Okay, in Y12 you reduce the spacing. I can say okay. Okay, so now you can right click and close, escape, right click and say update steel bars. So that section is sufficient. Update steel bars. Okay. Okay, this is insufficient because of the long length. It's not a problem. We can take care of it in detailing. So we have this. So now basically we have come to the end of our modeling. As you can see, this is our modeling is pretty the same like the architectural. This is what the architectural looks. So now we can go to analysis. Go to building analysis. Your loading generator, you already generate all your load cases and load combinations. And you can go to this setting center. Is this you can set whatever anything you want to set. You can set. Okay, the setting center is the same setting center that you can get it here. So now you can depict materials, your column, concrete columns. Okay, you can edit concrete columns. I already have. This is column, this is wall, this is beam, this is slab. So you select the reinforcements. These are the reinforcement diameters, these are their label, and these are the areas. So for columns, I take Y16 and Y20. For wall, I don't have a reinforced wall. Sometimes if you're in the area that you may have a reinforced wall, like you have a place, you have a lift in your model, and your lift wall are reinforced, so you may have to take this, so you can have reinforcement in your wall. Beam, I have 16 and 20. Slab, I have only 12. Okay, this rib slab I don't have. Footing, I have only 12. Links, I have 8, so I can say okay. Then I say okay. Say okay. Then I can go to analysis and run building model check if there is any error. See, there is no error. Sometimes you may have error. You may have like 2 columns being in one place, or you may have like a column and a beam not sitting properly. We may have like a slab crossing on a beam, and all those on error. So whenever you have error, you go to load editor and know what the error is, and you take note of the member that is having the error, and go back to your model to effect the error. Okay, as you can see, this one there's no error, so I can close it. So I can go to building analysis. So now I can select the members. I can reselect. If the previous one failed, reselect. No problem. Design. Okay, do you want to reassign default rebar to all existing? If it's already no existing pattern will be used. Do you want to reassign default rebar? No, I don't want to assign default. It will be the ones I selected. Okay, analysis has been done. Okay, now you can go to post analysis. You can check your beam, you can check your columns, you can see all your columns, all passed. But here we're having how many? Here we're having almost this, all here, have 14. Then let's open this and see, open one of the columns. Okay, and we can see we have, yes, they're okay. 4 at each corner, 1 1, and then with a 16. It's good. Okay, then let's look at the one that I have in 4 4. Okay, this is okay. Those are our 1 2 3 4. Those are our, the dimension is 450 by 150. Okay, this is good. 1 2 3 4 5 6, like we only have 6. Good. Okay, there are two of them. You can see our utilization ratio is good. Okay, fine. So you can close this. Check your beam. see. Okay, I have two beams are fade, so we can check why the utilization ratios are okay. 0.89. Let's know why they are failing. And beam A7, A6, and A10. So let's know why they are failing. We will click on it. Design is not valid. We want to okay. Depth, let's see. I20. Okay, let's change the pattern. Select pattern 3. I20. Don't need then we have 116 and see. I20. 2Y20. Okay, this web don't need anything here. Bottom bar. Okay, let me see. Okay, still not pass. Yes. Okay, here they're having issue with our links. Yes, they have the link. Let's have it 800. Okay. And now update. Update. Okay, 100. Update. See what I have in my look at the beams and fade and display visual interrogation. Okay. Display my design status. Okay, and look at properly the beams that I able that will not pass and why they will not pass. Okay, this beam, those are the beams that will not pass. Design section. Y16 they pass. So you can increase their 2Y16 they pass. 3 support. Y16. Make it 3 at the support. check. Same way Y. Y. Y 6920. 3. 116. 3. 116. Y20. Span. 3Y20. Let's go and do that. See? Then this here. Don't want this. Bottom bar 316. 316. Hanger bar 2Y20. 2Y20. Okay. Okay, you can see now. That's all passed. Let's go dig in 3D. Then pass like this. So now the next thing we do now is to go to our path. Our foundation 00. Do our path. Go to plan. Go to 00. And insert your path base. Insert pad footing. Wait for it. Okay. Here it has gone. 1 meter by 1 meter has straight. So the first is depth of 400. What is reinforcement in X direction? Reinforcement in Y direction, the reinforcement that is failing. So go to the bar. Okay, we'll use diameter X. Reinforcement. Reinforcement. Okay, let's go back to delete. Okay, let me see this. See the second one insert. Center reinforcement. Okay, I'm going to set my reinforcement for footing. Go to building setup, auto analysis, model building, edit material. Foundation Y12 close. Go here. Foundation general Y10 Y12. Check this. Maybe stop down. Okay. Update stickers. Insert pad base. The rebar. I see our rebar is already here. 200. Geometry 1 meter by 1 meter. Okay. And the 3D. Do the same here. Fast. Okay. Do the same here. Add base. Okay, 1 meter by 1 meter. Still pass. This start pad base. 1 meter, 1 meter. More past. Okay, maximum pressure. So that 14. The minimum, this one is 1 2 by 1 2. Okay. Okay. Now you want that is 1 2. Start. 1.1, this 1.1, maybe 1.2. 1.1 pass, 1.2 not pass. Combine footing. By 1.2. Yes. Basically, this is what we have, and with this we have come to the end of our modeling. So in my next lecture I will show you how you can detail your members, your foundation plan, your staircase, and how you can put your work in drawing sheets. Thank you, and stay tuned as you watch the last part.